This is a video concerning the continuation of the analysis of this example that was given to demonstrate that statistics comes after the objectives have been stated. So in this example, you have a research topic, which is a study of the significant factors that influence the learning of mathematics. And then from that research topic, you have a research question which says that, is there a significant difference in the mathematical abilities across gender? Now, to answer that question without data, that's called a hypothesis, a claim, which says here there is no significant difference in mathematical abilities across gender. So the objective now is to determine if there is a significant difference in mathematical abilities across gender. So now comes statistics, whereby the data has to be collected, organized. That means it has to be presented using tables and then represented using diagrams, and it has to be analyzed in order to decide and conclude. So the variable here is mathematical abilities. Now, since we are going to be verifying whether or not there is a difference in performance across gender, gender now appears to be another variable. So we have to identify two variables here, the mathematics performance, which can be measured by the score, and gender, male or female. And these two variables now are to be measured, meaning data has to be collected from them via a questionnaire, which is a data collection tool. And as you can see here, two questions are listed. What is your gender? So you can either put male or female. And what is your average score in mathematics exam? So you can put 50%, 90%. And this will be sufficient information to move forward to perform the analysis. And this comes right after the objective. So now we are into statistics. We are collecting the data. So now we are in the realm of statistics. First process to collect the data using a data collection tool. And in this case, we are using a questionnaire. So the questions in the questionnaire are determined by the number of variables that have been identified, starting from the research question. And they are also in the hypothesis, and they are also in the objectives. Two variables, gender and mathematics score. So two questions in the questionnaire. Now recall the process of statistics. It begins with the collection of data. The data has been collected using the questionnaire, and now it has to be organized, meaning it has to be presented using tables. So here the data is presented. Here it is. Let's just zoom in on this a little bit. So respondents or participants who ask their gender and their score. So for example, this participant said that they are female and they scored 75. And this was done for this particular case to collect a sample of, let's say, 39, because the first row is for the topic, gender and score. So here we have a sample of 39 individuals or students that were surveyed. And the data is now presented in this table. The next step is now to represent the data, meaning to present it again, but using diagrams. So here we first organize the data in ascending order to count how many females from 2 to 32. So that's 31 females and 8 males. And this can be represented on a bar graph. In this very document, you put a link. It's very popular, statisticskingdom.com, descriptive statistics, and we can use that to create a bar graph for gender. Go to chart maker, and here we are going to construct a bar chart, and the category here, we've got male and female. So here we input the data in a bar chart, 8 males, 31 females, and we click on calculate. And voila, here we have our bar chart. We are going to represent the score using a box plot or box and whiskers diagram. And here it is. The data now has to be placed back in its original form so that the analysis can take place. It will be a t-test, an independent samples t-test, because we're going to see whether or not there's a difference between male and female. Very same document, there is a link. You can click to go to the calculator for independent samples t-test, 2 samples independent test. So we set it for a total, that there is a difference between the 2 groups, male and female, and the significance level, we'll leave it at 0.05 by default. And now we are going to enter the raw data. Group 1, male, and group 2, female. After having rearranged the male scores and the female scores separately, as you can see, there is a big difference between the two. Just copy and paste into the program. We are now going to click on calculate and to analyze the output. So here we have some statistics that were calculated. And as you can see, the skewness is symmetrical, and the average for male is 76 and the average for female is 72. But we've got to see if this is significantly different. So we've got to calculate the test. We've got to perform the test. And what we need now is to get the p-value. The p-value is 0.3. So therefore, we are not to reject the null. And the null says that there is no difference between the 2 scores. Once the p-value is greater than the significance level of 0.05, you are not to reject the null hypothesis. As you can see, since p-value is greater than the significance level, the null hypothesis cannot be rejected. So therefore, we have to conclude that there is no difference between the scores across gender. Remember, the null is saying that there's no significant difference in mathematical abilities across gender, meaning the population mean score of the male is equal to that of the female. That's what the null hypothesis is saying. And since the p-value of 0.383 is greater than the significance level of 0.05, so the null hypothesis represented by HO cannot be rejected. So we have to conclude that the average male's population score is assumed to be equal to the average female's population score, in agreement with what the null hypothesis is saying. So therefore, this is an agreement with the claim, which is saying that there is no significant difference between the scores across gender.